My name is Dr. Conor MacCormack. I am the CEO and co-inventor of Mcor Technologies. The big developments for us, for Mcor over the last year, have been we have a new high definition, so we've even increased the colour of our definition even further. But in that process, we've reduced the price of the parts. And that goes along with the company ethos. We don't want to rip people off. We want people able to print and not to be holding them to extorting money out of it. So we increase the colour quality, but we reduce the price by new algorithms that actually jetted out a smaller amount of ink. So we're holding true to our promise of trying to make parts at a very, very low cost, and that's a big thing that we did. We've also doubled in the number of employees that we have over the year. We have, very good growth in terms of units. So, things are projecting well for the company, and it's all exciting. There's been a lot of talk about an industrial revolution. People talk about 3D printing as being the next industrial revolution. And as you know, over the last couple of years, there's been kind of a negative backlash out of that. The public companies, 3D Systems, Stratasys, their stock has fallen through the floor, but the growth is still growing at the same rate. But so my view is that the promise of 3D printing is real, but the expectations of where the technology was, especially in the desktop arena, it wasn't really there. So people were buying desktop printers thinking they were going to print an entire phone, because somebody said in 2012, the economist said that you could print out an entire phone, or people saying that this machine is going to change the world or change your life. But the reality is that the technology just wasn't there yet. However, so I don't believe 3D printers are going to cause the next industrial revolution. Because an industrial revolution changes everybody's lives. If you look at the first industrial revolution in the 1760s to 1840s, wherever it was, everybody's life was influenced by that revolution. Life expectancy of children, babies under 5, went from 75% down to 10%. Like 3D printing isn't going to cause that, but where 3D printing is going to cause a revolution, I believe, is in education. If you look at how children have been taught, like in 1350, there was a painting done of a lecture in Madrid, and you see the lecturer standing in front of a group of students, and the guys in the front are paying attention, and the guys at the back are going to sleep. Very similar to how lectures are being taught today. Students are either taking something from a blackboard, or maybe now they have it on a tablet, but it's still a flat. If you're learning Pythagoras' theorem or something, it's still a flat image. You can imagine what 3D printing can do to that. It'll enhance the learning experience. It'll make the children understand better, and I think that will be a revolution in education. It'll change how people will teach forever, and I think that's the big change that's coming. It won't be in industry, it'll actually be on the education. It's obvious that people always think about engineering, and that's the first port of call, or math, or maybe some of the sciences, but it's usually always engineering first. And then, the STEM, and then people talk about STEAM, where you put art in it, but it's really across the whole board. Like, I think if I have a 13-year-old daughter, and we went through her school book, and you take out a book of geography, and you can say we can enhance that learning by printing that. Take out a book in science, you can do in science. Take a book in history, you can learn history. So I think it needs to go across all the disciplines, all the various subjects, and you literally can find examples. And this is where our own technology, I think, plays an important role. It's one thing being able to print a part, but because we have the highest colour capability in our products, we believe that printing a photorealistic part. Let me give an example. So if you go to Smithsonian, you can print out a printout of Amelia Earhart's jacket, the actual leather jacket that she wore when she travelled from America, Newfoundland, to Ireland, actually, on her first solo flight. So kids can actually print it out in full colour. You can see all the marks on it. You can actually, there's a connection with history. There's a connection with the past, and it kind of almost centres the students. Yep. It makes them, they're not on the phone doing Instagram, and it kind of brings them back. And that's the big problem that history teachers have, is how do I connect to these students? Why are they concerned about something that happened 100 years ago? But if you can actually print it out, they can kind of be involved with it. But that won't engage everybody. Like we had a computer, a BBC B computer, and I didn't turn into a programmer, whereas other people got that computer and did. whereas I did something else. So it won't be math for everybody, it won't be geography, it won't be history, but if you can do enough of them, you will trigger somebody's curiosity, somebody's innovation, somebody's creative thinking will come out from these different disciplines. So it's not just math, it should be across the board. There are certain parts where colour is maybe not as important, but you can get a lot of more information across a colour than just the physical object. You know, we want objects to be a teachable object. So when you actually get it for education, that the object itself teaches something. And if you can make the students be more curious, they will actually learn themselves. So there's lots of examples. That was one example of Amelia here. There's lots of other examples where colour is really important. In engineering sense, it's a given. Like stress analysis, finite element analysis, your information about the strength of the material, how it's going to fail, all through the colour. But if you want to print somebody's face, so for example, the scan of Lincoln or the scan of Obama that was done in full colour, to be able to actually print it out in full colour, because there's a huge difference between printing something in white plastic or black plastic and then printing out a high bitmap image. It just looks like a person. It's getting closer to being a photorealistic. And the DNA really in our company, because we use ink and paper, we feel that we can get to a photorealistic quality, and we're basing that on 40 years experience of jetting out. So we're the only company that jets ink onto paper. Other companies that jet ink onto powder, they have a challenge in that it just looks different. It's difficult to get the sharp transitions that over 40 years these companies have developed, and we're standing on the shoulders of that technology, taking the line from Isaac Newton. We're standing on the shoulders of giants to push it forward, and that's 40 years of development. We're just stepping on and sticking it into 3D. So we believe, unmeasurably, our 3D printed colour is higher than everybody else's. Because we use paper, people say, well, how is it environmentally friendly? And when we deal with a lot of paper manufacturers, and I remember talking to one very big paper manufacturer in Sweden, and they make hundreds of tons of paper, like it's massive. And they get very upset at that question, because where they harvest their forests are actually growing. They're like a 100-year-old company. And over those 100 years, they've been planting, if they cut down one tree, they'll plant a tree for every tree that they cut down. So their forests, because they need to do that, they need a supply. So where they harvest for trees, they're actually growing. It's other places where they're cutting down trees to make roads, and that's a different story. That's deforestation. But actually, where people are growing trees for making paper, that actually is a growing area. So that's our combat to people talking about, you know, so people where we view it, it's at a relative level. If you look at paper and compare that paper to plastics, and powders and UV resins and all that, like we're orders of magnitude on the eco side. We're very, very green, very. We're definitely an R&D company. Like we outsource our manufacturing of the machine. We do all our internal development, all our software development, all our firmware development. We do all our ink development. It's all done in-house, and new machines. So we're constantly working on new things. We file a huge amount of intellectual property for a company of our size. We do a lot of IP generation. So yes, there is new stuff all the time, and we always get asked this question. So all I'll say is, if we weren't looking at new technology, I wouldn't be doing right as a CEO. We need to be looking at new stuff. And when we come out with our next stuff, it's going to leapfrog. There's no point in coming out with incremental changes, because it takes so long to build a printer. You know, it can take years from initial concept to something else. So when we do come out with new stuff in the future, when people see it, it'll be a big step forward, and that's what we're trying to do all the time. So yes, there will be new things coming in years to come, and nothing in the immediate, but there is stuff that we're working on, and so yes. And I think it's, you know, we need it. You know, there's lots of things that the industry isn't doing well. You know, speed is still very bad, materials is bad, you know, environmentally footprint. You know, there's lots of things that we need to get right. And but I think the big mistake that people make is that they think that all the innovation is over, that you might as well close the patent shop, that nobody's going to do any more patents. But as you see from more recent companies that have come out, you know, one guy, a student, a kid, a housewife, a doctor, a nurse can have an idea that can propel and bring it to the next level. So yes, we will have new stuff in the future.